Today's topic is maxima and minima of a function. So let's start with the topic. New pen here. Maxima and minima of a function. Three topics you have studied, and all those three topics basically were application of derivatives. Marker. Okay, application. This is basically, this topic comes in application of derivatives. And why it is so? Because we use derivatives. First was rate of change of tangent and normals. You use derivative effect. So that was application of derivatives. Other was increasing, decreasing. You check increasing and decreasing behavior of a function with the help of derivatives. If derivative f dash x is greater than 0, what you say? Function is increasing. So what you use? You use derivative. Okay. So now this topic maxima and minima is also application of derivative, because we will see, or we will check maximum and minimum of a function with the help of derivative. Is it fine? So this is also application of derivative, because many a times student ask na what's the use of, or like what derivative, like how derivative is helpful. So this is how derivative is helpful. You have seen two topics, this is the third one. Okay, so now maximum is very clear. You know how maximum means what? Maximum means largest value. If I draw the function like this, just start. Suppose your function is this. Okay, I think I just take it upward. This is the graph of the function, any function you consider. You see, in this interval, maximum value you can see. Maximum, this point is maximum. This is the maximum value of the function. Point is what? Point you check on x-axis. Point, if I say at what point the function is maximum, point will lie on x-axis. Value of at that point will be not on y-axis, on this graph. Value corresponding to that x, the value will lie on the graph. Fine. So this value seems to be maximum according as I have drawn the graph which I have drawn. This value is maximum. You can see. Then another value is this. This is also maximum. This is also maximum. But if you see this value, suppose the graph is stopping here. This is, I think, the biggest value now. So the value which, suppose this point is A. So this is FA. All agree? This is FA now. This is FA. So all the values of fx are less than equal to FA. All the values of the function. Okay. So it means FA is greater than equal to fx for all x in. If it is a function, it must have domain. It must have domain. We basically consider the domain only. We always consider the domain. So FA is greater than equal to fx for all x in D, where D is domain. So such a value is called global maximum. This is maximum point now. So this is global maximum or absolute maximum. It is clear that other values are less than equal to this value. Okay. So x equal to A point is maximum point. Point of maxima. Is it fine? And value at this point is FA. I hope it is clear. Now there are other maximum points also in the graph which we can see. This is also maximum. This is also maximum. This is also maximum in some particular like intervals. So these are local maximas. Is it fine? So this point is global maximum, global maxima. But there are other points also. Those points are local maxima. So this point is, at this point the value is this. And one more thing, at the point, please, this is very important. the point where, this is the point, at this point this value is maximum. If this is the maximum value na, if this is the maximum value, then derivative at that point, this is really very important, listen, at this point the function has maximum value in a particular interval. Basically on complete domain this is the maximum value. Okay, this is on complete domain we have one maximum, one global maximum, but there are in certain intervals we have other maximum values also. So this is maximum value. At this point derivative will be 0. Derivative will be, I'll write all those things but you just understand. At this point the value is, suppose this point is x is equal to b, so this point is fb, so 100% f dash b will be, last time I taught you tangents and normals. So if derivative is 0, what it implies, what does it mean in tangent form? So it means at this point the tangent will be parallel to, and you can see it. Okay, so derivative 0 means the tangent will be parallel to x-axis. One thing I am telling you, if this value, if at a point the function has maximum value now, so guarantee is the derivative will be, if the value is maximum or minimum. But if derivative is 0 now, then you cannot say anything about that point. Are you getting it? If that value, if at that point the function has maximum value or minimum value, derivative will be 100% 0. But in case at a point you are getting derivative 0, then in that case you cannot say that at that point function will have either maximum value or minimum value. So necessary condition for a point to be extremum point, we call those maximum value or minimum points as extremum values also. Okay, this is another name. So if we know that at this point the function has maximum value, derivative will be 0. If we know that at this point the function has minimum value, derivative will be 0. That is guarantee. In case if I say in general, suppose in a question you have this, then there is no guarantee at C. That C might have maximum value at x equal to C, function might have maximum value. I am not sure now. There is no surety now this time. Is it fine? All these things clear to you? So this is basically how to, this is basically what which point we call maximum, and it is very simple also. You can see by the graph also. But it is not always possible. I think in every class I say कि you can draw the graph of every function. So how derivative will help to know what are the maximum and minimum points and what basically the maximum value or minimum value of the function. Is it fine? So now this is okay. Global maximum you got to know. Local maximum you got to know. Local minima points are, this is the point. You just imagine at this point, suppose this is C. So this will be FC. F dash C will be, all agree? F dash C will be 0. So this is point of minima. Now this is also local maxima. This is local maximum value, basically you can say. Point is here, point lying on x-axis, but this is local maxima value. This is global maxima. So minimum, maximum you got to know. Now consider, suppose function is this. Sin x, I think it is very simple one, but sin x values you know. Sin x values lie between, domain is R, domain is R. You know sin x lie between, so it means maximum value is 1 and minus 1 is minimum, but there are many points where sin x takes value 1. So it will totally depend on interval. If somebody is asking you between 0 to pi, tell me the points where sin x will take 1 value. So you can check out all those points, because on R so there are infinitely many. if I ask you, like on R, tell me what are the tell me the points where sin x takes the maximum value. You know there are infinitely many points. What are the points? One is the maximum value. Where sin x function takes one value? All multiples of pi by 2. So n basically integer or natural number? Integer set is infinite. So there are infinitely many points. So but the thing is, I think in interval they will keep finite. Okay. So in writing I am not giving you anything now. But now one more thing. Then I'll give you a theory. If the function, for function you just notice that the function is continuous. Function is, but can you say that you cannot find out greatest integer function maximum value? You can find out now. You can easily find out. You can draw greatest integer function. But the thing is, now what we are doing application of derivatives. Greatest integer function we cannot differentiate. Okay, we don't differentiate in that way. Fine. So now the two methods I am telling you, and those two methods, your function should be differentiable. There are other methods also to find maxima and minima of a function, but the thing is, what the methods which I am telling you right now, for those methods your function should be differentiable. Then we'll see another method also. If there is a function which is not differentiable, then we'll go for another method. Is it fine? So now I write down the two methods. Okay, what about now? One more function we take, because these functions are known to you. If I ask you about e to the power x, what type of function it is? Oh, no, it is an exponential function. Function graph looks like this. Tell me the maximum value. And infinity we don't consider. No? We always write interval as like this. So infinity we don't consider it a point. We will not say at x equal to infinity the function having maximum value. Okay. So especially for this function, this function has no maxima point and no minima point. Infinity we don't consider. What about log x now? Log x basically graph is, it looks like this. The graph looks like this. This is basically inverse of e to the power x. So if the function doesn't have maxima and minima, inverse will have. Log x function doesn't have maxima and minima points. Is it fine? What about mod x now? What about mod x? What about mod x? I just rub the board because what about mod x? Okay, I think I should move step by step. First thing is, first method I'm telling you, because I think it's better to tell you the first method. First method is first derivative method. And how it works? What happened? First derivative method, because right now whatever discussion I did now, I did on the basis of the graph. Fine. So what's the use of derivatives? So we particularly interested in knowing the methods which involve derivatives. Fine. So first derivative method says, if suppose point is at x equal to c, suppose your function is, suppose we have function, this is the function, domain I am taking D. Fine. This is the function. Our function is fx. So for first derivative method, what you will do? First you will calculate f dash x. First derivative you have calculated. Then what you will do? Put f dash x equal to 0. You will get some roots. F dash x equal to 0. This is the equation. You will get some roots. You can easily solve. Fine. So roots you will find out. And you all know how many roots an equation can have. Okay, so suppose for this equation, this function has these are the roots of this function. Fine, C1, C2 and so on. At C1 now, and these points are called, these points we call stationary or critical points. Stationary or critical points we call. So roots we have found out. Now roots are this. So at x equal to c, I am doing the discussion now. At x equal to c1, if, what you will do now? F dash c1 I am just drawing the graph also. This is suppose the point C1, fine. Now what you will do, C1, you will go to C1 negative left. You will take points to the left of C1, okay. You will check if f dash C1 minus is negative. Negative means what? If your derivative, function derivative is negative, it means function is increasing or decreasing? Decreasing means what? Function is coming in this direction. Fine. Function is coming in this direction. I have already told you at C1 the function derivative is 0. Function derivative is 0, so it will touch na. It will be parallel, the tangent will be parallel to x-axis, so the curve will look like this. Now, if at C1, at x equal to C1 I am discussing, at C1 what you will do, you will take points left to C1, little change you will do, C1 minus h tending to 0. So f dash C1 minus, if this is negative and f C1 plus is positive. Positive means what? It started increasing. So this point you can easily see, if it is changing from negative to positive, this point will be 100% point of minima. Is it okay? If the graph is changing like decreasing to increasing, then it is understood that that point is basically point of minima. So if this is the change, if this is the change at x equal to C1, it means x equal to C1 is point of, this implies that x equal to C1 is point of, is it fine? This is only point of minima. Now at this point, if we want to know minimum value, what you will do now to know that? So minimum value will be of f at x equal to C1 will be f, yes. Is it fine? So this is first derivative test. Now in case, this is one point, if f dash C1 minus is greater than 0 and then it is changing in positive direction, it is less than. It means in this situation, the situation now, just this is one case, okay. Now at the same at C1 only I am discussing. So suppose now the situation is positive. Positive means it is increasing, okay. It is increasing means to the left, So for left points it is increasing, for the right point it is decreasing. So the graph will look like this. So in this case at x equal to C1 the function will have maximum value, okay. So at x equal to, in this case now you just note it down. Now from here, so in this case, in this situation basically, in this situation function will have maximum value at x equal to C1 and that value will be again f of C1. So these are two situations which can occur. At a point obviously either it will increase or decrease, only 2 points, if it is point of maxima or minima, if it is, otherwise there is no point If such a situation is occurring, you can say that this is point of minima, this is point of maxima. If such a situation is not occurring, it means you cannot say, you cannot talk on that point. What basically the function, function, what value the function has. Function is minimum, maximum, you don't know then. If such a situation is occurring, you are very sure, very confidently you can say that this is point of maxima, this is point of minima. Otherwise, you need some other methods to know exactly the behavior of the function at that point. Is it fine? So this is first derivative method. I hope it is clear. For you will get one function, you will differentiate, you will find the roots, and then at each point you will check the behavior of the derivative like this, and then on the basis of this behavior you can say that this is at this point this is the situation, or this is the point, like is minimum point or maximum point. Okay, now I think this is this first derivative method, this is basically, this is how you judge. Now come to second derivative method, that is actually simpler one. Second derivative method. I just rub the board. You must have studied it also. In class you have studied, in school. This topic you have already studied now. So now second method is second derivative method. Okay, one more thing, I think for the first method, function should be differentiable. That is must, because we are applying derivatives. We are using derivatives, so function 100% should be differentiable. So you can use, this is what I was telling you, for first derivative method, for second derivative method, if you are applying or if you are using derivative methods, your function should be differentiable. If you are applying these methods, if the function is not differentiable, then there is no point. Then you cannot say anything. Okay, then you have to use other method. So secondary method is, so obviously your function will be f from d to r. This is the function. First you will do again, you will differentiate f with respect to x. You will differentiate again, you will find the critical points, equate that derivative equal to 0, you will get the critical points. Then what you will do, you will calculate, because this is second derivative method na, this is second derivative method. So second derivative you will calculate second derivative. From here you will get points, suppose x c1, c2 and so what you will see now, at x equal to c1, how we will apply this second derivative method. At x equal to c1, you will check, you will put this value c1 in second derivative. If your second derivative is greater than 0, if this is the situation at the point c1, then what you will say? You will say x equal to c1 is point of minima. This is simple one na, no need to check to the right or to the left, that is difficult one. Okay, so this is simple one. Now if in case at x equal to c1, if your second derivative value at that point is less than 0, in that case this will imply x equal to c is point of. Now the thing is, how you start, I think you just finish writing. What do? You just equate your derivative equal to 0, you get some points, and on those points only you discuss, you do the discussion. Now I am giving you the necessary condition which I have discussed. Is this okay? Second derivative test you have already studied also. Now the thing is, I think these two mod x you are now very familiar. Mod x is, I think, the best example. Mod x example is the best example to understand the contradictory things. Fx equal to mod x. necessary condition I told you, I'll give you in written also. Necessary condition was if at a point, if a point is maximum point, at that point derivative will be 0. That is for sure, na? Now I'll draw the graph of this function. See, I cannot apply my first derivative test, second derivative test. I cannot apply. But I know the graph, and by seeing the graph, I can say this is global minimum. Because this value at x equal to 0, this value is minimum now. This is the minimum value of the function. At x equal to 0, f0 is 0. So this is point of minima. I can easily see. I am not applying any method. It is just a common sense. I can see the graph and I can say that at x equal to 0, the function is having minimum value, and that minimum value is, point is also 0 in this case, and the minimum value is also 0 in this case especially. So in this case the function having minimum value na. So what I told you, if we know that at a point, if a point is point of maxima or minima, the derivative should be, but this function is not derivable. You got to know necessary and sufficient condition. I hope you are understanding. You are understanding or not? I explain it. If you know that the point is point of maxima, at that point the function will have derivative 0. But here you cannot, this function is not derivable, na? This function is, you know na, this function is not derivable. This function is not derivable at x equal to, only the point is at x equal to 0, this function is not derivable. This is continuous. This function is not derivable. This function is not derivable at x equal to 0, but x equal to 0 is point of minima. F dash I can't talk. Actually f dash 0 I can't talk. I cannot talk. F dash 0, there is no discussion. I can't talk. Is it fine? So derivative thing not existing, but still there is a for this function point of minima is existing. So it means that there is no sufficient condition. This is the meaning. There is a necessary condition. Necessary condition says that if the point is maximum point, 100% derivative will be 0. But if derivative not existing or derivative is 0, we cannot say about that point. So this is the we have necessary condition, we don't have sufficient condition. So this is the difference between necessary condition and sufficient condition. So another example is, so what is the necessary condition? Necessary condition becomes now, if, no, I think second 2 times I told you, so I think you, necessary condition is if you know that at that point the function having maximum value. Okay. If you know a point x equal to c, you know at x equal to c the function has maximum value, then at that point the derivative will be 0. This is the necessary condition. But in this case you minimum point is existing, but derivative is not existing. So you cannot connect, na? You cannot connect. So it means if you know that at that point the function, if you know that at the point is maximum point or minimum point, derivative will be 0. But you cannot go conversely. Are you getting it? If you know x equal to c is extremum value, I'll give you in written also. I thought that you getting it like no need to give in written. X equal to c is extremum value. Then 100% this is the case. If it exists, okay? But here the thing is, by graphical method we cannot differentiate it. So we cannot apply first derivative method, second derivative method. But the graph, we used some other method, and by that method we are saying this is minimum value. But here the function is not derivable. Okay. So it means this is necessary condition also. We cannot go back. We cannot go back. Okay. So if only you know this fact only, you cannot say that at x equal to c the function having maximum value or minimum value. Okay. If the function is not derivable at a point, then also you cannot say ki at that point what behavior the function is having. Here the function is not derivable at 0, but so you cannot say anything using any method. So graph can clear you anything, but so it means this is necessary condition only. At 0 the function is not derivable, but at x equal to 0 the function having minimum value. Okay, so conversely you cannot go this way, you cannot go. Okay, is it fine? I hope it is fine. So now you can note it down. Another example you just take. I think I just write down the necessary condition. Write down then. Necessary condition, this is very, very important. Necessary condition for extreme values. Statement is a necessary, what happened? A necessary condition, please write it down, it will help you because you people are not getting it exactly. A necessary condition for a function to have an extreme value. Extreme values are basically maximum value or at x equal to c, the function necessary condition is for a function to have an extreme value at x equal to c is that f dash c is equal to 0. Is it fine? So maximum minimum value, extreme value means minimum or maximum. So f derivative will be 0 at that point. So tangent will be parallel to the x-axis. Now consider this example. You know the graph of this function? You know the graph of this function? How the graph looks like? The graph looks like this is the graph now. This is the graph. Is it fine? So now fx is 3x cube, f dash x is 3x square, f dash x is 3x square. Put f dash x equal to 0. What are the critical points? What are the critical points? X square equal to 0, it means x equal to 0, but f dash 0 is 0. F dash 0 is 0. If you will go any method now you apply, this will become, second derivative will become 6x. Fine. 6x. Now a second derivative method if you apply, so 6x basically, 6x will give you what? I think first derivative also you can apply. This is always positive. This is always positive. This is never like, it is not like negative positive condition, it will never give you. But at x equal to 0, derivative is 0 now. But you can see this point is neither point of maxima nor point of minima. But derivative is 0. Is it fine? So it means that if 100% we are sure that at this point, if this is the point of maxima, derivative will be 0, fine. But these are the two situations where you have seen function is not derivable, but point of minima is existing. At this point derivative is 0, but this is not point of minima or maxima. You can see it. Okay. So it means we need some other conditions also. We need some other study also that I think I'll tell you later. There is some condition where we can exactly get to know that what basically this point is. You must be getting confused how this is happening, but when I'll tell you the point of inflection point concept now, things will be clear to you. Point of inflection point, things will be clear to you. So this point is neither point of maxima nor point of minima. Is it fine? Now let me start with the examples. Are up the board? This condition you have already studied, or in class you studied it? This is the basically this is the only statement which we should know if we are doing maxima minima. Okay, very simple example now I am taking. Suppose this is the function. Domain of this function is real line is domain. Okay, don't think that always I am teaching you two methods, so don't feed in your mind that every time I'll use those methods only. You can use other methods also. So x cube plus 1. Okay, so which method you want to apply? I want to know of this function point of maxima and minima. So is there like easily you can figure out, or you will use any method to answer this question? First derivative method you can apply. First derivative will be 3x square. Point of critical point is how many? 1 only. Critical points are is only x equal to 0. This is the only point. Fine. Now x equal to 0. Say first derivative. If you will go to 0 minus, what you will get? Positive. If you will go to 0 plus, you will get positive again. So it means what? By first derivative method, no conclusion is coming. By first derivative, you can apply, this will always be positive. You go to 0 negative side, or you go to 0 positive side. So first derivative method you cannot apply. Now second derivative you can apply. Second derivative will be what? It will be 6x. Can you say anything about this? That it will be completely like at 0 is the discussion point. So 0 is the discussion point. At 0 this value, this is basically having 0 value now. This is having. We can conclude if we are applying second derivative method, then if these are the situations, then only we can answer anything. If this is the situation, we cannot answer anything, but we can answer. Now I think I should tell you what we will do now, because second derivative is 0 now. We can conclude, or we can answer on the basis of second derivative test if these are the situation. Okay, but our situation is 0. We are getting derivative 0. So what we will do? We will calculate third derivative at the point 0. So third derivative will be 6. 6 is non-zero. 6 is non-zero. It means if such a situation occur now, it means x equal to 0 is neither the point of maxima nor the point of minima. Okay, so on after this, side by side, I am telling you point of inflection. The point of inflection means the point which at this point of inflection is the point where the function doesn't have maximum value or minimum value. When this situation occurs, please understand this. You take any function, you calculate derivative, you equate that equal to 0, you find out some points. Okay, you get the roots, suppose only at one point only I am discussing now to tell you the concept basically. So get roots, and suppose one root is this. Okay, what you do then? Second derivative you calculate. Fine. Second derivative you calculate, and what you see? If these are the situation, you can answer something in the sense, if this is the situation, a C point will be point of maxima. If this is the situation, point of minima. And now consider, in case f double dash C is 0. Please understand it. If this is the situation, what you will do now? You will go to third derivative. At that point. If it is non-zero, if it is calculate, I think calculate third derivative, if this is a actually lengthier process. If this is 0, if this is non-zero, then to this point is point of inflection. It means this is neither point of maxima nor point of minima. If it is non-zero, so write down, in such a situation x equal to c is point of inflection. Point of inflection means neither point of minima nor point of maxima. You cannot say anything. So neither point of minima nor point of maxima. Now consider if you have noted down, if the situation is again it is 0, now just imagine, now I am repeating the process, please, I think it will help you. Now I am repeating the process. What does it mean? Odd derivative 0, you check the second even derivative. Even derivative negative means point of maxima, even derivative positive means point of. So now I have my odd derivative 0. So what I will do now, I will check the fourth derivative. If fourth derivative is less than 0, it means C point is point of maxima. If it is greater than 0, it means it is point of minima. Okay, understood? Now again assume now, if suppose if this is 0, what you will do now? You will calculate the fifth one. Okay, sometimes it happens. Okay, not like in all the questions, but sometimes it happens. The thing is, now fourth derivative 0. What you will do now? You will go to fifth derivative. Fifth derivative, in case fifth derivative is non-zero, then what you will say? It is neither point of minima nor point of maxima. Then if it is 0, the fifth derivative is 0, then you will check the behavior at that point with the help of the even derivative, and that even derivative will be sixth derivative. So this is how you move on. This is basically generalization, you can say. It is generalization, na? Earlier we were just taking these two. So this is odd derivative, this is even derivative. So this is odd derivative 100% has to be 0. It should not be non-zero. Is it fine? So this is the method. So you can note it down. So in such a situation, x equal to c is point of maxima, and here it will be point of minima. So point of, if it is non-zero, then what will happen? If it is non-zero, then what you will do? Then what you can say? No, if it is non-zero, Shiva, then 100% is either it will be less than 0 or greater than 0. I didn't do anything, I just changed something. What I did, I just changed, like if f4 dash c is not 0 means what? Either it is greater than 0 or less than 0. It means something you are getting, either point of minima or either point of maxima. Is it okay? So if it is 0, in that case you go to the next derivative. In that case only you go to the next derivative. If it is non-zero, then there is no need to, no? If it is non-zero, then there is no need to go to the next step. Is it fine? Okay, now I think theory part, lot of theory part we have done. Come to the examples now. '98 paper question I am taking for very first question. I just rub the board. If you have any doubts, please ask, because so many things, I think you might be confused. Is this point of inflection thing is clear to all of you? How we check, how we move on? Because I will check, I will use this method. That is why I am telling you. There are questions, in those questions I'll use this. That if second derivative is 0, I'll move to the third derivative. And then I'll go to the fourth. Okay. So now very first question is, can you draw the graph of this function? Okay, I think before that, note, if a function is continuous on a closed and bounded interval AB, then there is 100% surety that the function will have extreme points. Is it okay? Continuous. Anything which is coming in your mind on the statement which I have written? Continuous function I am taking, and that continuous function is on this interval. Any function you can draw, that function will be differentiable. Any function you can draw. You must be thinking, I think, differentiability thing. You can draw any function. Okay. So if you have continuous function, interval is closed, then 100% there is surety that that function has 1 or 2 or 3 extreme values that function will have, for surely. If this interval is not closed now, then there is no guarantee. If this is not closed, then there is no guarantee. You cannot conclude, or you cannot be very sure. Then you have to check. But if your function is continuous on a closed interval, then 100% you can whether you will be confirmed that it will have extreme values. Is it fine? So now this function, I think this is 98 year question. What we will do now, which method you want to apply? I think the second derivative method is simpler one. Second derivative method. So first we have to differentiate this function, quickly differentiate this function. Differentiating with respect to x. Tell me quickly derivative. I'll write it directly. I'll save time. Four x by. Is this you are getting? Okay, now can anyone tell me, is this function continuous? Is there any point where this function is not continuous? This function is continuous. Upper one is polynomial, lower one is polynomial, and lower one is not equal to 0. So p by q form, p is continuous, q is continuous, q is not equal to 0. So this function is in all continuous. This is the derivative. Now what we will do? Put f dash x equal to 0. So what point you will get? Only x equal to 0. So first derivative method if you apply, this term is already positive, whichever value of x. If you will go to x negative side, so this will be negative. If you will go 0 minus, so this value will be negative. If you will go to 0 positive side, it will be. So if this is the behavior change, so it means x equal to 0 is what point? So this implies x equal to 0 is point of, some are saying minima, some are saying maxima. Less than 0 means decreasing, and then it is increasing. So it means x equal to 0 is point of minima. Now second derivative, please tell me quickly. Second derivative. Quickly tell me. Are you getting your second derivative? Are you getting it? I have written the answer on board. You just match your answer with my answer. This is the answer now. So second derivative, what second derivative is saying? At x equal to 0, f double dash 0 is, it should be greater than 0 now for point of minima. This is greater than 0 at x equal to 0. So any of the method you can apply. Any of the method you can apply to know like the behavior at the critical point. Is it fine? Is it fine? In case I am just telling you, in case you are getting this 0, what you will do? What you will do? Okay, now I am asking you, suppose this is the situation, what you will do? It means what? It means what? Point of inflection? No. Point of inflection is in this case. If it is not 0. If odd derivatives are 0, you go to even derivatives, and even derivatives, according to even derivatives you check the behavior. Is it fine? So if after just in this case, if this situation you are getting, then you will go to the fourth derivative to know maximum minimum situation. If this is the situation, then you will say at x equal to 0 is neither point of minima nor point of maxima. Is it fine? I think now it is clear to you. Now next example. Question is fx ax e to the power bx square. Is this function continuous? If fx equal to this attains maximum value at 1 at x equal to 2, find a and b. Find a and b. Is this fine? Is this function continuous? ax e to the power bx square. I don't know what ab basically the values of ab. Values of ab I don't know. The only what is maximum value 1 at x equal to 2. What does it mean? You want to try? Okay, do it. Because you have two unknowns, so what two situations, basically two equations you need now. So two equations will be okay, 1 minute I am giving you, try. Anyone? Anyone? Okay, I am doing it. your function is this, derivative will be this e to the power bx square 2bx, then a I'm taking outside, then e to the power bx square as it is. Fine. So this is the derivative. Common I can take out as, so 2abx square plus 1. Is it fine? So we are given maximum value 1 at x equal to 2. It means f of 2 is at 2 maximum value f2 is 1. This is given. F2 is 1 given. Now I am giving you that at x equal to t the function attains maximum value. It means f dash 2 will be 0 for sure, na? So one situation is this, f dash 2 equal to 0. So a b, did you solve in the same manner? A, yes, a also outside. A will be outside now. Fine. E to the power bx square plus 1. So now f2 equal to 1 giving us f2. So 2a e to the power 4b equal to 1. This is one situation. f2 equal to 1. Now f dash 2 equal to 0. It means this term equal to 0. So this term will give us f dash 2. So x I should put a e to the power 4b 2 8b plus this I am getting. Is it fine? Two equations I have written on board. You can check. Now from this equation, please, from here, so because a and b both are there, na? I can't conclude anything. From here you just see this term never 0. All agree? This term never 0. So this into this equal to 0 implies either a is 0 or b is minus 1 by 8. Is it fine? If a is 0 here, if a is 0, no value you will get because this is non-zero, and I think that is absurd also. You can check. If you substitute 0 here, this is non-zero term. If you will multiply 0 into something, so this will give you nothing. I think that is absurd kind of. So you cannot take this. This choice is not good. Are you getting it? A0 basically is not satisfying this, and it should satisfy both the equations. So b is equal to minus 8, giving you what? Tell me a value then. B equal to minus 1 by 8. Put up here and tell me a value. What a value you are getting? Is it okay? Why we are not taking a0? Is it fine? Because if you take a0, na, this a0 will not satisfy this equation. You want a and b values which satisfy these two equations. So a satisfying this, but a is not satisfying this. So you cannot take a0. So now for corresponding to b minus 1 by 8, what value you are getting? Under root e by 2 you are getting? Or I do it? Under root e by 2. I do it? Okay. You got it? How many of you got this under root e by 2? And the fact that why we are not taking a0. This fine, na? Now the thing is, sometimes I think we know that we have got the right answer, but the thing is, these a and b values gives us surety that at x equal to 2, the function will have maximum value. It means I substitute a here, b here, okay. Second derivative at x equal to 2 should be less than 0, na? For to be very confident or to know our answer is correct, we should check, na? Are you getting it? Second derivative corresponding to these two values at x equal to 2 should be less than 0 if it is point of maxima and if our answer is correct. If our answer is correct. So you just tell me second derivative. You just tell me second derivative only. I know it will be bigger one and it will be 100% less than 0. Tell me the second derivative and just check for these two values. whether it is negative or not. Are you getting it? Negative? I think what you can do, you can at home you can try f dash 2, f dash 2, 100% it should be less than. Now I think because this is actually the lengthier one, please look on the board. The thing is, we did some calculation according to the given situation. We did some calculation, we got this answer. Now the thing is, to be very sure, we should check this also. Now I am just doing the another question, and after that question you will understand why we should check this. Why we should check this. Okay. So now let me do that question first, but you will check this at home. Okay. This is not difficult one. What you have to do? A, you have to substitute here under root e by 2, and then under root e will be positive, under root e will be constant. Okay. Then under root e by 2 x e to the power b is minus 1 by 8 x square. Then you will this is the first derivative, you will differentiate it one more time, and then you will substitute x equal to 2, and you can check that either positive value you are getting or less than. But in case, because we are given maximum value, so it should be less than 0. It should be. And why you must be thinking that we have got the answer, so why we check second derivative, na? It should be 100% less than 0. You must be thinking. So let me do the second question. The next question to know this thing. Why we have to calculate. Okay, now the next question is fx equal to a by x plus x square. Find a if f max at x equal to minus 3 fine. So what we will do, what we are given, function we are given, we have to find out a value if f is maximum at x equal to minus 3. So it means f is maximum at x equal to minus 3 means what? What we have? What we have? Derivative will be 0, 100%. Okay. So solution fx is so derivative will be minus a by x square plus so derivative will be 0, f dash minus 3 will be 0. This will give you what? This will give you from here f dash minus 3 will imply minus a by 9 minus 6 equal to 0. So it implies a is equal to minus 54. According to the situation we did everything, I think. So according to the situation, this is the answer. Now it seems that this is the answer. If this, what we are saying, find a if f max at x equal to minus 3, find. So now what next thing should be, at this is the a value, only one a value we are getting. So it means at this point second derivative should be less than 0. So f double dash 3 should be less than 0 for corresponding to this value. Corresponding to this value, second derivative should be 0. So just check it. Second derivative will be what? It will be minus 2 by x cube. So 2a by x cube plus 2. All agree? It should be less than 0 corresponding to a minus 54, just check it. 2a, so 2 into minus 54 upon minus 3 into minus 3 into minus 3 plus 2 less than 0. So, okay, wait. A positive you are getting? No, A value minus 54 is okay. Who is saying positive? Negative value actually. So this should be less than 0 because F is maximum. So now this value is how much? This value is how much? 6. 6 you are getting? Just do the calculation. Six, na? So it is contradicting, na? Whatever situation we were given, according to that situation we got one value. But here this is contradicting. Is it fine? So for that question also you will check, and I think for every question you will check to know the for the confirmation. I hope you are getting it now. We got some value. We know we are 100% sure if F max means maximum value. So this is the situation. So A is minus 54, but this is not satisfying. So there is no A. There is no value of A. Is it fine? No A is existing, na, for this situation. So we should check the second derivative, or we should check this thing for the confirmation. I hope you are getting it. For the previous question also at home you will check, and it will be. For that question I know you will get the second derivative less than 0. Is it fine? Why we are doing it? Why we are doing it? Why we are checking? Why we are not sure? Anybody has answer? Why we are not sure that this value is not the proper one? Not. Why? Because I have given you two examples. First was mod x, that was not derivable, but point of minima was existing. Another was x cube. At that point, derivative was 0, but that point was neither point of maxima nor point of minima. So this thing only cannot give us any guarantee. Okay, so this thing only doesn't give any guarantee. So we should check everything properly. So we have necessary condition also, we don't have sufficient. So if we have sufficient condition, then so there is no need to check anything. Then there is no need to check anything. So we till the date we don't have any sufficient condition for this maxima and minima. So it is fine. So there is no existing, there is no A for this situation. Now next question, add up the board. I think this function derivative I want you to do. Find extremum value of, most of the things you are doing. Find extremum value of x to the power 1 by x to the power x. You know the derivative of this function, na? Quickly do it and tell me, because derivative I need. So your fx is 1 by x to the power x. And when I will do, I'll just write it f only. I won't write it fx, because it makes our writing pattern simpler. So do the derivative please. We have to find out maximum value of this function. This is very simple one, derivatives you have done, so I want that all of you do it. Done? Anybody who doesn't know how to differentiate? Done? Raise your hands, those who are done, so that I can ask anyone. Raise your hands now one more time. Okay, not like everybody is not like able to, huh? Those who are having problem, why, what problem they are having? Because this is simple one. If you don't know the differentiation, it is really serious. What do you do? Just apply log on both sides because this is in power. Now please look on the board now. Just apply log on both sides and now differentiate with respect to x. So differentiation of log x will be 1 upon f, then f dash. Yes. If you are comfortable with this f dash, this is very good because df by dx is something very complicated one. Now differentiate these two terms. So this is basically some people what they do, they write this log 1 by x na minus log x. So it makes our calculation simple. So I can write it minus x log x. So now derivative will be minus this, then minus, is this fine? So derivative is minus 1 minus log x. So this is the derivative. Now how I am writing it? Because I want critical points now. So 1 upon f dash, I keep it here, f dash. F will go to that side and f is minus 1. I can take out common also. Is this fine till here? Now what I have to do? Put, to know the critical points, f dash equal to 0, I'll equate. F dash equal to 0 means 1 upon x to the power x minus 1 minus log x equal to 0. What about this term now? On real line, is this 0 anywhere? Huh? Is this 0 anywhere? Because I have two numbers in product and product is 0. So either this is 0 or this is 0. But I am very sure this is never 0. This is never 0. So it means minus 1 minus log x equal to 0 implies log x is equal to minus 1. So x is equal to 1 upon e. All are okay with it? How we get this? Is it fine? So x equal to minus 1 by e. Only 1 point we got now. 1 point we got. So now the next thing is second derivative we will calculate and we'll put up this point and we'll see that it is minima point or maxima point. The question is how we differentiated one more time. How we differentiated one more time. I know that after a long calculation you can differentiate it. After a long calculation obviously you can do it. You will keep it as it is. You will differentiate it. You will differentiate it. You will no. You will keep it as it is. You will differentiate it. Then you will keep it as it is. You will differentiate it and then you will put up this 1 by e point. Okay. So but we have to learn the simpler method and just see. I need that side. What I'll do, I'll differentiate this and how I'll do it, please learn. This is 1. So differentiating 1, how I'll do it, see. 1 by f dash, okay. So this is product. This is product of two functions. First derivative of first will be minus 1 by f square and then f derivative will be f dash and one f dash already we have. Is it fine? So it will be f dash whole square. Is it fine? Now next will be 1 by f as it is and then f dash derivative will be double dash. Fine. Take the derivative on the right hand side. So and right hand side derivative will be only. Is this okay? Now why I did this, why I used it, because if you go from here, if you find second derivative from here, there is something. Now at x equal to 1 by e, derivative is 0. So it means this term is, because I have to check second derivative at 1 by e. Okay. So it means directly this term is 0 now. Directly this term is 0. So second derivative, now my second derivative only is f double dash 1 by f. I can take that f to this side. Okay. So only I am left with minus 1 by x into f. F is this. Is it fine? So now I'll check that quantity behavior. If it is less than 0, I'll say point of maxima. If it is greater than 0, it is point of minima. Are you getting it? Because at this point the derivative is 0. So I don't this first term is get cancels. So I am left with these two terms. So I left this. I just rub this. So it means f double dash 1 by e basically is 1 by e into 1 f. F is 1 by x. So 1 by x will be e only. Okay, and x will be 1 by e. Now tell me this quantity. Is this negative or positive? All can answer. E into e 1 by e. Is this negative quantity or positive? Because e value is how much? E is negative 2 point something na. So this is negative quantity very clearly. So it means at this point the function has maximum value. So I hope that you are getting that this differentiating this equation is simpler and very useful also. So I think in other questions also you can use it. So but this is the point of maxima na. This is the point of maxima. So at x equal to e 1 by e, at x equal to 1 by e, the function has maximum value, and that maximum value is how much? As how much? E to the power 1 by e. Sometimes straightforward questions comes that a maximum value of this function, then 4 options you get, and then you check. There is another method also. If you are given that this is the maximum value or this is the point of maxima, then what 2 things you should check? Directly second derivative less than 0, and that at that point derivative should be, these 2 points helps to know the answer quickly. Is it fine? Okay, now okay, before this I just rub the board. What about this function now? Let me see who will answer. What about this function? Do it. Point of extreme values you have to tell me. What values you are getting? What are the values? Is this fine now? What's the problem? So plus minus iota by under root 3. This is fine na? What's the problem here? Actually the thing is that we at our level we are doing real functions. So our domain is real. It doesn't mean that this is complex number. So you can check the behavior for complex numbers. We must be having some other method na for complex functions. So it doesn't mean, but for our case we don't have any maxima minima point because values are complex and we don't deal with complex functions. Is it okay? We don't deal with complex numbers, so we'll leave it. So there is no point of maxima minima in this case especially. Is it fine? Okay. Now question is, your fx is gx x minus a whole square, ga is not equal to 0. You have to answer like where the function will be for critical points, how your function will behave, and you have 2 functions basically in this case. Fx is related to gx and ga is non-zero. So I don't know critical points, nothing I know. So what I have to do first? For what I have to do? Extreme values basically you have to answer. Extreme values of f. So first derivative will be what? First derivative is how much? 0 and what you are saying? Just check your first derivative is this or not. If your first derivative is this, it is fine. Otherwise, this is the first derivative. What I have to do? I have to equate it to 0. So equating it to 0, I am getting two terms. Fine. Either this is 0 or this is 0. So from here I am getting x equal to a. This will be 0. This will be 0 or non-zero or what? If anybody will answer, I'll be very happy. Why I am not bothering in this? I am not bothering like, but why I am not using this term? Why this term is not so special? GA is? Okay, that is fine. X equal to A, I am getting. GA is non-zero. Fine. So GA, but I am not like only for A point I am not concerned. Na? There could be other points also. Like if we have this type of equation and suppose x is 2 I get or x equal to, so from here also I might get some points, na? I might get some points, but why I am not concerned? You just solve this na little bit. Do it. 2gx equal to 2gx will be minus x minus a g dash x. Okay, so you are getting some points, no na? Particular x points you are not getting, na? For to get particular points, what you should know? Your gx. You don't know your gx, so how you can find out x points from here? You cannot find out, na? And 1 point you have already got. If you don't know gx, if I say anyhow you from here you got to know gx is 0. So what x values where it is 0 you cannot find out, na? If you don't know your gx. Are you getting it? So this term is not useful because you don't know gx. You don't know gx, so suppose ultimately you get gx equal to 0. So what values of gx? What values of x? Is it fine? So clearly this is giving me a clear point, but this term is not giving me clear point. So at x equal to a I will check now. This is the critical point where I can check. So second derivative, anybody please calculate. This is helpful to you. Second derivative please tell me. And this is simple one. Don't complicate it. Second derivative just tell me. I am writing it on board also. Only the final answer I am writing. Are you getting it? I have written the answer on board and do it very quickly also. What? The same answer you are getting? Fine. So at x equal to a I have to check. So f double dash a, how much you are getting? This is 0, so 2GA. Fine. So now your double derivative totally dependent on GA. 2 is positive. No one has any issue. 2 is positive, so only now your f double dash is depending on GA, and I have given GA is not equal to 0. No clear like indication whether it is greater than 0 or less than 0. So I have my two paths now. So case 1 will be if GA is greater than 0. So f double dash A will be 0. Greater than 0, it means x equal to A is point of minima. So point of minima. If GA less than 0, it means f double dash A is. So question will be like that, for extremum values like GA, and it will totally depend on GA. So GA less than 0, this is less than 0, so at x equal to A is point of maxima. Okay, now take another question. This is also good one. I have the board. If fx, write down the question. If fx equal to sine square x. Okay, simple question also. I think it is coming in my mind right now. What about this question? Maxima and minima points. What is the maximum value of this function? Very good. Minimum value? So f at what point? I think many points, huh? Many points, na? So those points I am not asking you. Maximum value is and minimum value is fine. So such questions also come. What about this? I think I am. What about this function now? What about maximum and minimum value this time now? Five, 6? Confirm? What values you are taking for this now? Yes, fine. It's fine now? Such actually straightforward questions also come. It's not that very simple question I took. My point is that sometimes graph helps, sometimes method helps, sometimes direct calculation also helps. So you have to be very careful like which method quickly you can apply in a question. So now if fx is sine square x, A is cos x, find A if fx attain exactly 1 point of minima in 0 to pi. 0 to pi is the interval this time. So what we have to do, because we know one method only, graph is very difficult one. So derivative will be, derivative is how much? F dash x will be, okay, I am not writing it. Who is saying sin 2x? Who is saying sin 2x? Answer is not wrong. You are saying, na? Actually point is because I have to find out x values. Okay, if you equate sin 2x, now what problem we will get? I am writing it directly now. Okay, you will get to know like why I am not changing it. 2 sin x cos x is fine. Then derivative of this is plus a sin x. So here I am not writing because I can take out something common, and when I'll equate it will help this term only. If you write it sin 2x, then you know you cannot take out anything common. I hope you are getting it. So we write whatever we write for our convenience only we write. So at this step I will not write sin 2x, fine. So sin 2x, sin x I can take out common. So I left with 2 cos x plus A. Now I have to equate it to 0. So put f dash x equal to 0. So sin x, how many values this time I am getting? So this implies sin x equal to 0 and then cos x equal to minus a by 2. Fine. So sin x equal to 0, how many values? 1. Which one? Pi by? Pi by? Some are telling me the right answer. One thing, this is open interval. So domain, you can have idea. We consider domain points now for this differentiation thing. So x equal to what point you are telling me? Quickly answer na, then come up with the answer. No value, it means what this into this equal to 0 implies either this 0 or this 0, but this is non-zero in this interval. So this will not give us anything, so we will consider this only. Fine. Is it fine? Now tell me, cos x equal to minus a by 2 I am getting. Cos x equal to minus a by 2. I have to find out a now. So cos x values between 0 and pi. It lie between cos x between 0 to pi have values between cos x 0 to pi. At 0 it has cos pi. So it means this value, and you know that cos also lie between minus 1 to 1 na, so this value will lie between minus 1 and 1. All agree? Because I don't know exactly what value this has. So but I know this will lie between minus 1 and 1. So it means minus 1 minus a by 2, it can be equal, because 0, why I am not writing equal? Yes, open interval. So pi is 1, so it means a is lying between minus 2 to 2. This is fine. But exactly I didn't get to know na what a value is. So what trick I should use? What is the next step? 2 to minus 2. This is the very unique interval you are telling me. Then I have changed it na then. I have changed it na. But obviously minus 2 will come to this side na. I cannot say 2 less than a less than minus 2. I think nobody writes actually the interval like that. Whatever you are saying na, that minus is there. So inequality will change. Obviously it will change, and you can see minus, when you will multiply it by minus, so it will become positive. Inequality will get changed. So it will become like this. So I think both are same. Is it fine? So don't think that I haven't done that thing. Is it fine now? So this is the thing. Clearly A I am not getting. Fine. So next thing what should I do? You know now for maxima minima, next thing is second derivative. Second derivative should be, if it is point of minima, second derivative should be positive na. Quickly find out second derivative. Now you can take, what's your name, cap person? Shalini, now you can write sin 2x because it will help in like differentiation. So it will be, second derivative will be, second derivative at minus a by 2 will be greater than 0. Can I rub this side? This side I can rub na. So tell me quickly, what relation you are getting? So I think my answer is f double dash minus a by 2 is 2. I think first I should write f double dash x. Anybody got it? So f double dash x I am getting as cos 2x plus a cos x. All are getting it? 2 cos 2x and then this. Then cos 2x formula is 2 cos square x minus 1. Why I am doing it? Because I know cos x is minus a by 2. I can use cos x. So I need to write the formula for this. Then only I can use cos x equal to minus a by 2. Na? So this is the thing. This is final now. Now I can substitute. So this is f double dash x. So f double dash minus a by 2 will be, it will be, now I am substituting it. So a square by 4 minus 1 plus a into minus a by 2. Is it fine? You can simplify it. Ultimately you will get a square minus 4 by 2 equal to 0. All are getting it? I hope so. So after this you will get this. After this, can you say a less than 2 union a inequality? A square is greater than 4. It means either a will be less than minus 2, a will be greater than 2. Now you see, this thing is basically for the minima point I used, and this is also for the point of minima, but both are contradicting. A is lying between minus 2 to 2, a is lying between this, so it means there is no a, there is no such a lying in that interval. Is it fine? So there is no a value because this is completely contradicting, no value you are getting, so there is no a.